Hello everyone, and so in this section we're going to actually compare JavaScript and Kotlin, because you would probably have done more JavaScript than you would have Java. So even though we have a set of cards up there that kind of look at J2K, okay, in just for the videos we will just look at JavaScript. So again, I've split it across two parts, part 1 and 2. Part 1 we will just look at some of the basics, and then in part 2 we will look at slightly some more advanced features, like with in terms of it would look at deeper into the collections, some kind of asynchronous programming and so on and so forth. Okay, so just to begin with, if we look at our variables and constants, very similar as before, and this we would have touched on this. So Kotlin variables are declared with the var keyword, like we know. To prevent reassignment, you can use the val, okay, and both work much like JavaScript's let and const. So okay, so if we have our val here, okay, in our Kotlin, from JavaScript we would have said something like const. And again, if we want to have variables that we can change, we can use the let, and then we can kind of declare but not assign or not initialize, and we can do the same down here. So here's our var is alive, give it a value, or we can just explicitly give it a type and not initialize it. But remember, you have to do one or the other. You can't just can do it something like this in JavaScript. Okay, you have to either specify the type or a value, so a kind of an inferred value. Okay, so that's like just our variables and constants. In terms of strings, just a couple of little examples here. Here we have, we're saying in Kotlin, we're saying val house is assigned Stark, whereas up here const, right? So kind of familiar with that. And if we want to have, if you can remember when we were looking at our syntax early set of slides, we had the triple quotes there, so we can actually have text running over more than one line. And to do so from your JavaScript days, you would have been using the single quote there. Okay. So again, that's just a little bit on kind of comparison of strings. A little bit more about strings. So string interpolation. You've probably seen a Game of Thrones theme here. So you can, if you look at the full reference, you'll see why. But anyway, here we are saying const action, right? We're saying it's just a string there as our text. Attack using a $ curly brackets weapon. So again, something very similar to what we would see in Kotlin. So we can say something like here, $ weapon. The only difference is that if we want to get at from JavaScript, just accessing the variable, we still have to use the curly brackets, whereas in Kotlin we don't. We can just say $ weapon, and that will then replace whatever weapon value happens to be in our string. Okay. If we want to execute an expression or call a function up here, with our JavaScript, there it is there. So we're saying looks like you will, and then $x curly brackets user.getFate. So we will just you kind of call the getFate function on your user object. Very similar in our Kotlin. So $ and then curly brackets. There it is there. Whatever we want, user.getFate, same as same result you get as you would in JavaScript. Okay. In terms of functions, so again we've seen this before. If we look at a function in JavaScript first, so up here, and how we call it, so we can say function double num. Return num times 2. Again, no kind of specifying of a type, it's just a variable, and then we return it times 2 here. Okay, whereas down in our Kotlin we would say something like function double num, but we again have to specify a type, so num int, and then return num times 2. So very little difference between the two there, and we would actually call it the same way as well. We could say double and then get pass it in a value. We could just drop the semicolon in Kotlin. In terms of some default values, we'll look at this in a little bit more detail on the next slide, but here we can say something along the lines, here's our function. Again, I suppose major difference there, it's function as opposed to fun. right? To identify a function in Kotlin. But back to our JavaScript, we could say something like this here. We can say function shout, passing in a couple of parameters. Here we have just message on its own, but we're also specifying another one there, postfix, and passing in a value. Excuse me. In this case, just our 3 exclamation marks. And then we can return, there's a bit of string interpolation going on there. We can have our curly brackets, dollar curly brackets, dollar curly brackets, something else. So we're saying invoke that function to uppercase on our message option and append to the end, so to speak, when we're returning it as a string, the postfix. Okay, and then we can actually pass in, there's our text, but because postfix has the exclamation marks, what we get actually printed out is the string converted to uppercase and then appending the 3 exclamation marks. To do something similar, or to do the same, should I say, in Kotlin, something along these lines, very similar again, just making sure that we identify the type. So we're saying message of type string. Here's our postfix again with the value, default arguments, should I say, and then identifying a type. So again, that wouldn't be the case in JavaScript. And then we return, so it again doesn't look as cryptic, I suppose, invoking the message dot to uppercase and then postfix at the end. So again, we would get the same, if we could call it like so, we would get the same result. Okay, so that's just dealing with named functions. In terms of named parameters, we would have covered this again, but I suppose just to talk a little bit about it, or to recap, in Kotlin, function parameters can be named when calling functions. So as we're doing up here, okay, this is very convenient when a function has a high number of parameters or default ones. You can't do this in JavaScript, so this is a nice addition, so that we can have our variable specify its type and then give it a value. And so the more we have, the more kind of understandable, readable it is. Okay, we could call it like so. We could say something like there's a reformat. We could pass in a string here, right? But here's the difference. We can actually give it a different value if we want. So we can name the variable that we want to give a value to override the default value. So you can't do that in JavaScript. Okay, so one big difference there. In terms of function expressions, again, not 100% sure if you got to this in previous modules, but essentially we're looking at the arrow notation, or arrow functions, sometimes referred to, versus our lambdas. So again, up in JavaScript, we would say something like this. We could say const double is assigned, and there's a kind of anonymous function, so to speak, using our arrow notation to get the code body, or the whatever we want actually to evaluate in our expression. So very simple here, just doubling our num. To do the same thing in Kotlin is something like this. So we say val double is assigned, and we use our lambda expression with that, our little arrow in there as well. We have to specify, again, the argument list here, we have to specify the type, whereas here we didn't. Okay, and then we execute the same. So we get our num times 2, and that's what's evaluated in the double value. Doing a little bit more if we want. So we can say here const square, right? So we're kind of, as I said, multi-line, right? We're saying our const result is assigned num times num. So again, like your anonymous function, there's our open curly brace, there's a closing curly brace. The same thing in Kotlin. It's a little bit more concise, a little bit nicer. Okay, and the main point to note here is the last expression in our lambda is always considered the return value. So here, this is the last expression, so that will be seen as the return value. Okay, and yeah, I suppose nothing else to kind of mention there. Just the syntax obviously is slightly different, but you can see there. Look, val result num times num. The actual statement there is virtually identical. Okay. In terms of a little bit more about those function expressions, right? And this is where the it or it single parameter comes into play. So it's very common that a lambda expression has only one parameter. Okay, as a convenience, Kotlin gives special treatment to this situation and automatically declares a single parameter under the name it. So to look at two examples here, in our JavaScript world, we would have something like this. We would have we could say const car models is assigned cars. Here we are calling our map.map. We pass in the reference is car, and we use our arrow notation, and then we have our car.model is what we want to map in our from cars, so to generate a map from that, right, based on the car model. Okay, whereas in our Kotlin world, a lot more concise. We just say that val car models is a car.map, and we don't need to pass in a parameter because, as I said, there's only the one argument, so we don't need an argument, and we can just access directly it.model, so that we get in at the individual model property of the cars object that is pointing to. So again, quite tidier than the JavaScript equivalent. If you wanted to do a little bit more, so again, for using our filter up here, look, back in JavaScript, you could have, for argument's sake, we have a users collection. We're saying users.filter. There we're passing in the user object, and what do we want? How we want to filter is that user.age is greater than or equal to the value 21. To do that, do the same in Kotlin is a lot less verbose. We say users.filter and simply it.age greater than or equal to 21. We don't need to access the individual argument because there is just the one argument. Okay. So that's again just a kind of some subtle differences between JavaScript and Kotlin when working with function expressions, and that the arrow functions versus our lambdas in Kotlin. Okay. To talk a little about flow control, so the first one there, very common, are if else. Okay, so in JavaScript we'll say something like this, say if our condition, in this case number greater than 0, do something, or else do something else, right? In this case just a console.log. Virtually identical in Kotlin. So same condition, just a slightly different statement to print it out, no semicolons, but other than that, identical. So again, no major difference there between JavaScript and Kotlin. In terms of kind of some other little examples, right? Unlike JavaScript, right, and other languages, if is an expression in Kotlin, and it can return a value. So in JavaScript, if we wanted to assign a result a value, we would have to say something along these lines: declare it outside the if statement, there's our condition, and then update it inside the matching condition. So if number is greater than 0, we will do this, else we will do this. But as I say, because in Kotlin if is an expression, we can say something like this. So we can say val result is assigned, and then our if statement, and this is the result that is returned and stored then in our value result. So a lot neater, a lot tidier. Now you can still do it this way. You could still declare your val variable up here and assign it in here, but you may as well make use of those nice little features that Kotlin has. And again, that happens to be one of them, that the fact that if is an expression, we can use it in this way. Another little example. So in Kotlin, right, you can leave the curly braces out if you're writing in one particular line, as we see an example there, and because of that there is no ternary operator. So in our JavaScript and even in Java, we can say something like this. So we declare a variable, we can then have a clause, or a test, shall I say, condition. So if number is greater than 0, we have our question mark and then our full colon. So that's the ternary operator. So this is what's assigned to result if it's true. Otherwise, or that's like the else part, else we get our negative number gets assigned to result. Now, to do the same in Kotlin, we can leverage the if statement again, because it is an expression, and we can say something like this. So we have our if, our condition, there's our result, else there's our other result. Again, a lot tidier, a lot neater, a lot easier to understand, I suppose, if you get right down to it. Okay. In terms of a switch, which would be replaced by when. So here, if we just look at this example here, here's a quite large switch statement in JavaScript, very similar to Java also. So there's our kind of particular condition we're testing. And if you look at it, we have, sorry, no, just change some there. We have all our different cases, so you can see it there. And we have a default at the bottom. So we'll get quite long-winded, a lot going on for kind of very little result, or little kind of what we wanted to do. Okay, simply printing out a log to the screen. Okay, if we want to do the same in Kotlin, it's this much neater, much less verbose. We simply have our when clause. There we go, and if whatever our selected fruit, if it happens to be orange, we print that out. And even this one here, look, our mango and papaya. So to go back and look at what it was in the equivalent in our JavaScript, we had to use 2 separate cases to match with that particular one. Whereas in Kotlin, a lot easier to kind of to understand and read when we're developing it. Okay. So again, it's a big difference there between switches in JavaScript, which is the equivalent to a when in Kotlin. And on top of that, when can also be used as an expression. So we can use that the same way we used our ifs. So it is a lot more kind of powerful than the basic switch statement. Okay. To look at loops. So Kotlin does provide a for loop, but it only works with iterators. So you generally use it with lists and maps, right? But fortunately for us, Kotlin also provides ranges, right? So iterators which can be created using our ... operator. So in our JavaScript world, we might say something like this. So there's our for let I is assigned 1, just kind of printing out 1 to 10. Another example here we have our const places. So okay, just a little array, JavaScript array of strings, just 3 different places there. And then we can say for const places of places, we can just print that out. And there we are using our string interpolation, just getting at the individual value to print it out, I love whatever. So that's what we'll actually get printed to the screen. To do the same in Kotlin, we can say something like this: for I in 1.10, print I straight away, much neater and much tidier. Same for our the second one there, working with arrays, in this case a list of, right? For places, in places, println I love $place. So again, a lot neater, a lot tidier. Okay, and I think that wraps up that little section. There's our reference there, and you can see there's just a kind of a part 1 at the end of it there. So I will be looking at part 2 in the next set of slides, and we will focus on collections in a bit more detail, a bit about asynchronous programming, and that will kind of just hopefully give you a little bit better kind of crossover from JavaScript to Kotlin. Okay, so thanks for listening, and goodbye. Okay, so welcome back to our part 2 of our JavaScript to Kotlin kind of comparison. So just to begin with there, we'll look at a couple of slides on collections. So in JavaScript, we will say something like this. So again, just creating our const house and just a basic JavaScript array there, just all strings, again, our Game of Thrones theme there. And we can access them like so. So we can say houses and the square brackets 2 to get in at that the third element. So again, index is starting at 0. We can add to it with houses.push, and then we can find the length of it with the .length property. Slightly different in Kotlin. So we'd say the equivalent would be something like this: mutable list of. So there's all our elements again like before. Accessing them the same with our index, but instead of push, we'd say add. And instead of length, we say size. So again, very similar. Couple of subtle differences. Just to talk a little bit about some other functions that we haven't covered in the syntax section, I think are quite handy to know about. We might say something like this, and so in Kotlin, So here's we can say val colors and create a map. There are 3 elements indexed with the key is kind of like the string, and the actual value then will be the hexadecimal representation of it. But we can say something like this. We can say colors dot plus, which is a nice little function, which doesn't change the original but creates a new one, stores it in our updated colors, and then adds that next or other element to it. We can have another example here. So here's another one, just creating a list, again certain number of elements stored in houses, and then we can say houses dot take 3 dot map, and then we have an expression. So essentially what this will do is, you can see the result there, all right, it'll take the first 3 elements from houses, convert it to a map, and convert each element to uppercase and store that in updated houses. So a lot going on there in one kind of line of code. And in the last one there, we can have, if we want, we can update, reassign that updated houses, and we can say houses dot to mutable list and carry out a couple of things there. So we can say again the original houses, convert it to a list, and then apply this particular expression here to add Martel back to that particular list, and then I convert that to a list. So a lot of chaining of different functions, passing in lambda expressions, so quite a lot going on there. And that they are kind of, that's not evident in JavaScript. Okay, so that's kind of new stuff that we can do in Kotlin. To look at a little bit about objects and how we will create objects in JavaScript. So objects, they serve a lot of purposes, mainly as a hash map, that key value pairing, but it's also the base construct from which everything except the basic primitives in JavaScript are descended, and lots of other utility functions there as well. So that object type is quite useful in JavaScript. So we can we might say something like this. We can say const colors, just giving all these different values, and then we have our properties there, a couple of functions there. Look, colors dot has own property, and then get in at the individual element, colors dot yellow, to return that what it would be in this case, just again the hexadecimal. Something what we would do in Kotlin would be like so. We'd say there's our val colors, creating a mutable map. Same thing, key to value. But here we say colors dot contains. So the function there is to find out, is it in or does it contain that particular element. So we're passing in yellow here, and then to return it, we'd say color or dot get. So again, some subtle differences there. Okay. In terms of destructuring assignment, this is actually quite useful. So the destructuring declaration syntax can be quite handy, and it'll save you a few lines of code when we'll actually talk about the example now in a minute. Essentially, when you assign a collection to a value, excuse me, Kotlin breaks it up and matches the sides against each other. So assigning the values on the right hand side to the variables on the left. So if we look at this one up here in JavaScript, here we are creating our coordinates, right? Basic JavaScript array with 3 elements, 5, 10, and 15. But we can also say const x, y, and z is assigned coordinates. So that will actually assign 5 to x, 10 to y, and 15 to z, all in the one statement. So we don't have to do individual get in at coordinates 0, 1, and 2 and then assign it. In Kotlin, it'll be something very similar. So here we are saying our val coordinates, converting it, creating an instance of an array, so array of, with the same elements, and then we say val, so it's the brackets as opposed to the square brackets, sorry, the braces as opposed to the square brackets. Same thing, and then that just assigns x to the coordinates. Now, you might think that looks a bit strange, right, and where would you use it? But can be quite convenient when dealing with functions that return multiple values. So if we had something like this in JavaScript, we could say a function here, weather report takes a location. Again, and this is only kind of just for demonstration purpose here, just for the explanation. We might make some AJAX call there, some request to get the weather. That returns back an array, a one element array containing a value and a bit of text. So we can then, if that's returned from the weather report, we can say in one line of code, const our temp and forecast inside our array, the weather report function, and then whatever location we were looking up. In Kotlin, it's very similar. So we could have a function like that and return pair. So again, that pair is a standard class in Kotlin that just represents that key value pair, okay? And we can say something again like this: val temp comma forecast is assigned a weather report, and then whatever. So we're passing in the one element, and we're getting back one return value, right? But it has two parts to it, so to speak. It's one element, sorry, should I say, being returned, but actually has multiple parts to it. And then with that deconstructing assignment, we can just assign one to the next, okay? As I said, in the one line of code, okay? I have to talk a little bit about classes, excuse me. So again, much like in JavaScript, Kotlin, we use the keyword class for both in JavaScript and in Kotlin. So here we have a full class here. Not a lot, to be honest, just one. We have a constructor and we have one function called speaks. You can see it there. We have to explicitly name the constructor. We're passing in 3 parameters here, using our this reference to populate name, color, and numize properties of the class. And if we have a speak there, we can just return in particular a string. Here we are, some string interpolation going on there. So we're using our dollar to get in at whatever the name is, get in at whatever the likes value would happen to be. And if we create them down here, very similar to Java, we create our element var name here for some reason, and is assigned new class name new. So I suppose the point I'm making here is we're using the new keyword, which is identical to Java, and then passing in whatever parameters we want, and then we can call a function on it. This example here, speak, just passing in a string, and we get that text printed out. Now, if we compare that to Kotlin, a lot less verbose, a lot more concise. So here's our class here. Much smaller, much neater. Explicitly identifying in the constructor what parameters are being passed in. Again, no explicit need to write the constructor or use the constructor keyword because we only have one constructor in this example. And then we have our simple function, again, our string interpolation there going on, just accessing $name, $likes. And the one point to note, when we create an instance of it, there's no new keyword. We just go straight to the class name and then pass in the parameters as we need. And the function call is the same as would be in JavaScript and even Java for that matter. Okay. A little bit about data containers and our data classes. So in JavaScript, it's commonplace to create plain objects to group named values together. In Kotlin, we will use the data class, and we will cover that now in the material, and it's a big part of the case studies that we're looking at. So here we can say, look, const movie1. Our curly brackets there, just a name, a rating, and a director with values. Similar to JSON, actually, if you look at it, curly brackets, we have a property and a value. And there's one we're doing for const movie2. Okay, so we have 2 individual data elements, I suppose you'd call them. Whereas in Kotlin, we would say something like this. We can simply say data class, whatever. So we prefix the class declaration with the kind of the data modifier that identify that this is purely a data class. Specify the properties inside our open and closing brackets inside the constructor, and that's it. And then when we go and create it, we say something like so. There's our val movie1, val movie2. Again, no new keyword. We're just going straight to the class name and then passing in whatever parameters we want to instantiate that particular object. And so there we have movie1, movie2. Okay. Talk a little bit about nullability again. We would have touched on this in some detail in the previous syntax presentations. But looking at this example up here, right? So in Kotlin, we can say var greeting full colon our string explicit declaration, but we can also say or reassign it. I say greeting is assigned null. Now, if you remember back in JavaScript, right, that has 2 non-values, so to speak. It's kind of undefined and null. And undefined is used to inform the absence of a particular value, and our null is generally used to explicitly set something to a non-existent value, which you can then check against. But a lot of the time that causes more trouble than it's worth. And what you would, if you probably have come across this error at some point, the uncaught type error, cannot read property X of undefined whatever, or type error null is not an object, whatever. All that is driven by the fact that you're trying to access an object that could have been null. Kotlin, as we would have covered already, does away with all that. Okay, so by default, Kotlin assumes that in this example here, greeting cannot be null. Okay, to allow null values, you have to declare a variable as declare a variable as nullable by appending a question mark in its type declaration. So sorry, if you see up here, right, even though it is a var, right, because we haven't used that question mark, right, this will actually get picked up at compile time. Sorry about that there. So we can say, if we do say var greeting and declare the declaration, that's fine. If we try and reassign it and we haven't flagged it to potentially hold a null value with the question mark, the compiler will pick that up and say you can't do it. So what you have to say is something like this down here. So we can say here our var nullable greeting full colon, and that's the key part there. We're appending the question mark to the end of the type declaration there, and then assigning it a value, so that at a later point, if we go ahead and reassign that null, that works fine. Okay, so if we look at taking that example a little bit further, right? So for example, the following method at access works because Kotlin knows that the variable greeting can never be null. So we don't need to wrap this up in some kind of checks or just making sure that, oh, maybe it will be null, maybe it won't. Kotlin knows that greeting cannot be null. It cannot have been allowed to be declared to hold a null value. So we can just simply say and check greeting.length and it'll work fine, right? But the same method call won't work with nullable greeting. So if we say something like this, right, again, we will get another compilation error because we're not specifying that, or we haven't specified, should I say, the null greeting being null in the previous, right? Now, if you handle a possibility of a null value, right, for example, stick it inside an if statement, right, then Kotlin will accept it and it will work no problem. So if we look at this on the next slide, right, sorry, do I have an example there? Or sorry, I don't. Okay, so if we look at our a way around it, right, trying to use those if statements or trying to wrap it up in some kind of a check, right, we have this thing called the safe call operator. Okay, so if we look at an example up here, right, what we're saying is val A, give it a value, val B potentially can hold a null, and we actually do give it a null value, right? But we can say, without any checks or any explicit, should I say, if statements, right? We can say println A the full or question mark dot length, B question mark dot length. So that's saying potentially this A value might be null, this B value might be null, and it will still allow it to print that out. Okay. And if you want it, you can actually chain multiple safe calls like the following. So here we are saying our val current city, we're saying it potentially can hold a null, so there's a question mark, and then we can get in at these individual properties and chain those safe calls. So here we are checking a user object, excuse me, within the user object there's probably an address field, and within that field there's probably a city property. So at every stage we can check to see if it could be null, right? So such a chain returns null if any of the properties in it is null. Okay, so just to talk a little bit about the Elvis operator, again, we would have covered this in the syntax section. So if you want to provide a default value, if some variable could be null, right, you can use the Elvis operator. So we say something like this. We have our val, declare our name. There's our what we're looking for, or what we're checking, should I say, right? And if that happens to be null, we're saying assign it the value guessed instead. Otherwise, obviously, assign whatever this value is to this variable here. Okay, and you can use the safe call operators, right, or any other expressions on the left hand side of an Elvis operator as well. So here we are. Look. So we're checking to see if the name property of that nullable user, right, could be null. If it is null, assign that. Otherwise, assign our name property to our val name. Okay, just so different examples of how to use that Elvis operator. So it could come in handy if you are writing code and working with a code base where properties and variables could actually be null at some point. Okay. The last thing I just want to touch on there is asynchronous programming. We haven't covered this yet, but we will in a couple of weeks. So just to briefly talk a little bit about it, and the kind of comparison between JavaScript and Kotlin, right? JavaScript is a single-threaded language that uses an event loop to allow asynchronous behavior. And again, so Node, if you're writing any kind of server applications, you're probably familiar with Node, and that's a kind of a single event loop, single-threaded model approach you're taking, right? And we have this notion of callbacks, and more recently promises, and the await async pattern. Okay, however, Kotlin is multi-threaded, right? So you can spawn multiple threads and execute code concurrently, and it also has built-in coroutines, and that's what we're going to look at later on, a coroutine mechanism with support for deferred, which is kind of like our promises, and that async await pattern. So, but in both cases, right, it allows you to write asynchronous code that looks like synchronous. So if we look at these two examples here up the top, it's very similar to kind of a straightforward function that we would write. There's none of those. If you've come across, probably did it with the JavaScript actually, that callback hell, and there's if statements inside if statements, and you're checking inside other, and just kind of this recursion thing going on. Here, it looks very sequential, it looks very synchronous, just one method call after the next. And there's our async, there's our await, here we are returning a promise. Whereas in Kotlin, we'll say something like this. We'll use our keyword suspend, prefixing a particular function, and then we will call, or in this case here we're returning a list of our current user deferred dot await. So we'll be using a dot await function on a particular object. But as I say, look, we haven't covered that yet, but we will get to it when we do cross over to our new version of, or the other case study, that donation case study. So we'll have actually two running in tandem. I'll be kind of focusing on donation, bringing in some asynchronous programming, making RESTful calls, hitting your JavaScript API that you would have built in your web apps module, and then Eamon will continue on with the place mark and bring in other kind of more advanced features there. Okay, so there's our couple of references, as our parts 1 and parts 2, and that's it on that little kind of comparison, some similarities, some differences between JavaScript and Kotlin. And thanks for listening, and goodbye. Hello everyone, and welcome to our final code walkthrough, version 4.0. In this version, it's virtually the same as the last version, but with some one significant difference, in that where our place marks were only persistent throughout the duration of the program, now we're actually going to write them to file, and we're writing to a JSON file. Okay, so that's what this version mainly does. We bring in another feature, we bring in a delete, but the main thing we'll be focusing on is the serialization mechanism within this version. Okay, so again, just to recap again, just the kind of things we've looked at. These are all the features, quite a lot of them, and most of them they're now covered, both from part 1 and part 2 of the syntax. So there's quite a lot going on in this version. To look at the project structure, so again, if we can just see it over there, we have in our models, we now have an extra class in there. We have our placemark JSON store. Okay, and as we'll see now in a minute, that will kind of implement that same placemark store interface, and we'll make a few changes to that. So we also have, if you notice here, we have a little helpers package with a file helpers file stored inside it, which is just basically a list of functions to help us excuse me, read and write that JSON file. Okay, so we'll look at that now soon enough. And I suppose just a point to make as well, I've tried to follow as closely as possible the same approach that Eamon has taken. So we will be seeing this again in the JSON section, but in the Android world. Okay. Just highlighting again that we have our helper file, and within that then there's JSON support as well, built into our PlaceMark JSON store a class. We will also be using Google's JSON, which is a really nice library for as I said, converting to and from JSON, and we'll be making use of that, and we'll see that in the dependencies as well. Okay. So to look at the kind of the main files and main classes in our main.kt, same as the last time, we have just one instance of our PlaceMark controller, and we call the start function, and that essentially just kicks off the whole application. Okay. So again, no changes there really from version 3. In terms of where our classes and interfaces in our version 4, we have a new function. We've added a new function, delete. Okay, takes the same parameters as before. So whereas in the previous version, we would pass in a PlaceMark object, excuse me, for creating and updating, we're now going to do the same with delete. So try and follow that same approach there, keep the same pattern. So again, this is additional delete function to allow for full CRUD support in the implemented classes. So when we're finished with this version, we will have, as I said, full CRUD support there. Okay. In terms of the PlaceMark JSON store, okay, so again, remember in the last version we had our PlaceMark mem store implementing the PlaceMark store interface. Here we are now, we have our PlaceMark JSON store implementing the PlaceMark store interface, and this will allow us, with very little changes, to swap in and swap out that different kind of support. Okay, and again, we'll see that in the lab, and we will see something similar then in the Android labs as well. Just a couple of points to note there too. We initially, where we had basically a simple array list, we now have a mutable list. Okay, and that's kind of relevant in terms of, because we're going to be writing this to file. So when changes are made, we might want to store those out. So we need that to be changeable. We have a few extra functions down here to carry out the specific serialization and deserialization, so writing out the disk and reading back in from disk or from that JSON file. So that we've added those to the PlaceMark JSON store. And again, notice there are private functions. So again, they're only accessible within, can only be called inside PlaceMark JSON, so it can't be invoked outside of the class. Okay. So this implements, again, PlaceMark store interface, allows for PlaceMark objects to be stored in a JSON file using serialize and deserialize, and we will look at those in more detail in the next few slides. So what we have here is not quite a couple of lines of code, that's all, quite concise. So if we see here, inside our serialize, right, which will write it out to disk. Okay, we are using, and you can see there, we're saying val JSON string is assigned JSON builder dot to JSON, takes two parameters, the PlaceMarks, which is that our list, which is this up here, and that gets passed in down here, and what is very important, a list type. In a nutshell, it basically tells JSON, or tells the Google's JSON how to store the JSON version of the class that you have. So this will determine how this PlaceMark is to be converted into its JSON equivalent, and again we will look at that in due course. But if we just look at the serialize function itself, it does one thing, or two things really. Converts our PlaceMarks, mutable list to JSON, hence the toJSON function, stores it in that JSON string, and then we have this other function called write, which we'll also look at in due course, that writes out that JSON string there. If you can see it here, writes out that JSON string and to a particular JSON file. This is just a variable we will assign the file name. So because we're using a constant here, it allows us to change the file name just the once at the top of the class or wherever, and not have to make changes everywhere that we were using that file. So wherever possible, it's actually good practice to use constants for things like file names and what have you. And we can see the example here for the deserialize. So when we're reading back in, all right, we would from our placemark JSON store, we would call the deserialize function, which will read in a JSON or read in a string, a basic string from that same JSON file, store it in this JSON string variable, and then we pass it to our JSON builder again, just using it slightly differently here, right? And we say our JSON dot from JSON. So that's going to say convert this basic string, and there we have our same list type telling Google's JSON how it's supposed to convert that string back into a whole list, or in our case mutable list of placemark objects. So it's a fairly powerful library, and we essentially just have to work with two different functions, the to JSON and from JSON. From to JSON, we just give it the list we want to convert to JSON, tell it how to convert it. Likewise, from, when we're converting back to a list, we pass in the string, which will be our JSON string, and again telling it what to do with it, how to convert it. And that's essentially it. It's really nice library to be working with. Okay, but we will look at now in examples later on. To expand and look at more detail inside our file helpers file, here's our write function. So again, here's the whole thing here. Okay, and if you notice there, we're actually using a lot of the classes from the standard Java file IO library. Look, there's we're saying if we have a file object, we have an output stream writer variable to declare or instantiate as an output stream writer, and there's our file output stream. So if you've done any kind of file handling in Java, this is basically the same approach. So this here is just writing out. It takes two parameters up here. We have our file name and our data, which is the string we want to spit out. We create a new instance of a file, and we have our simple try and catch. We haven't actually seen any of these up to now, but again, because this is working with the Java library, we need to catch any exceptions that could be thrown. So we create our file output stream a writer based on the file. So we'll literally attach the string to the file. We write out all the data in one go, which is that one string. We just make sure we close the stream to flush it out so that all the data is stored correctly, and that's it. That's our write. Now the read is a little bit more complicated, but we'll just focus on the write here first. So the main purpose is to write out a stream of data to a file, and that data is stored in JSON format. So what's passed in here, the data that's passed in is actually the JSON representation of our place marks. Okay, and again, I'll take you through the kind of serialization process in later parts of this section. Okay, so our read, as I say, is a little bit more complicated because we're reading in a string. Okay, so if we look at it here, we take the one file name, okay, reading back in, and returns a string. So that's going to be that the string that we want to return back from our read, right? We are creating here an input stream reader. So again, similar to before, just same rules apply here. We can only use input readers for reading in. We can only use output readers for writing out. So we can't kind of mix and match. So we need separate streams for both, right? We then use our buffer reader, which is attached to that input stream reader, okay? And what we're doing is we're basically using a string builder to build up that whole string that we're reading in from the file. And we have a simple while going on in here. You see here. So while we're initially set done to false, so while not done, through that buffer reader, we read in one line at a time. Okay, that's the way this works. I can only read it at one line at a time. And if that line is not null, we have our partial stir dot append that particular line. So we're kind of one line by line reading up that whole the data from the file. We then close off our input stream reader, and we then convert into one big string that partial string that we have been appending to as each line in the file was being read. okay? And that's what then gets returned. Okay, so the main purpose here is to read in a stream of data from a file. So that, and then that stream of data, which is our JSON string, is passed to our Google's JSON. If we just go back for a second, or just go back a slide there for a second, just go back a bit. If you see it here, here we are. There's our read. So it reads in that JSON file, returns the string, and it's that same string that's passed into our Google's JSON converter, and converts it then as needs be. Okay, so it is just quite a lot going on, but I'll break it down into the different steps, different stages, to hopefully make it a little bit more understandable. Okay, so again, that's just a look at our read. So we've looked at our write and read inside our file helpers file. These are just separate functions that we can call wherever we want. So the actual serialization mechanism itself, so to break it down, the general kind of steps that our whole application goes through. Okay, so the first thing that happens is app is launched and a placemark controller object is created and started via our .start. So again, we've kind of touched on that. It's the same as version 3. That's what we get. Okay, we then go ahead and through that start, the placemark controller creates a placemark JSON store object. Okay, like so. So that's what we have here, declared inside our placemark controller. And again, if you can remember now, we could very easily, there's our placemarks, because of the design we've tried to follow at the MVC, we could very easily replace that with a placemark mem store, and then we actually we're back to our original functionality. So by just changing that one declaration there, we get the two different representations because of the way we designed with the MVC and that's the approach and that separation of concerns. So makes for very kind of flexible application here. But anyway, just sticking with our JSON. So that's done. That's created inside our placemark controller, which in turn inside our placemark JSON store, which creates its own internal list of placemark objects for the app, and that's our mutable list, and that's what we write to, and that's what we read from ultimately. Okay, so that's the kind of the first couple of steps. The next thing, we check to see if a file already exists, right? Placemarks is populated with the data from the file via our deserialize function. So we have a little there's a kind of a good use for our init inside the class itself. When we initially create the class, we do a check on our JSON file, and if that exists, we deserialize. Okay, so that reads from that file, our JSON file, and again converts the JSON into its Kotlin equivalent at that mutable list, right? Otherwise, the data is written to the file every time a new placemark is created, updated, or deleted with serialize. So if you see here in our just showing her now, in our override function, okay, so we are passing on a placemark object. Just that's what we're passing, and we've instantiated that from the user passing it in. We generate an ID. We have a new function there, generate a random ID. This is purely for storing the JSON. We add it to the placemarks, our mutable list, and then we excuse me, and then we serialize that to disk. We will write it out to disk. So now, as I said, there's a couple of different approaches you could take there. You could, when the application launches, you load it up, and you could just read and write update delete directly to placemarks. Otherwise, and then wait till the end, wait till the application actually closes down. But this way, we're guaranteed that at every juncture, at every time the user creates, updates, or delete, we serialize, we save. So if God forbid something happened and the program actually did crash, our data is being backed up as we go through it. Okay, so just to continue on there. Okay, so to look at the files in total, we have the first thing that kind of happens, if I highlight it up here, as we said, inside our placemark controller, we create our instance of a placemark JSON store. There's also there's the view and our logger stuff as well, but that we're focusing on the serialization mechanism here at the moment. Then inside, so that we've created it there. Okay, then inside our PlaceMark JSON store, there we are creating our mutable list, and that's what we will read to and or write to and read back into, write out. There's our init, which checks to see if the file exists and if there's something in the file. Then we deserialize. Okay, so what does our dear deserialize do? Sorry, it reads from the file the raw JSON string, and using Google's JSON converts it into that PlaceMarks and updates the PlaceMarks mutable list. If we on our create, you can see it there again, what do? We will add it to our PlaceMarks so that is obviously available to the user, and so any changes that are made. But more importantly, we serialize, so we actually write out that change to the file as well. So we overwrite the existing file, and that's the same for update and delete and the rest of them. Okay, so that's kind of looking at a kind of an overview of them all together. And again, sorry, just to highlight as well, in our file helpers, right, there's our read and write, and the exists just the functions just to be allow us to read and write the raw data, the strings, and check again, does the file actually exist? Okay, so in terms of the dependencies, we have the main one there. So there's our Google's JSON. Okay, at the time of writing, the version was 2.8.5. that may be a little bit different if and when you come to do the lab, complete the lab. But as you know yourself, it's just a simple case of changing the version numbers, and actually Android Studio will prompt you to and suggest what's the latest version. Okay, so that's the one change you would need to make in your application to allow us access to that library. In terms of how we use JSON, just to show you some more stuff there. So we create the JSON builder like so. Okay, so that's the object coming from the library. So we're saying our JSON builder dot set pretty printing. That's kind of optional, but it's nice for formatting, so that if you want to view the JSON file, makes it easier to read, which we'll see in the next couple of slides. This is another important bit here. We define the object type. So if you see it there, the syntax looks a bit strange, but essentially we're declaring our list type, right? We say object, right, and it's of type token, so it's of type object, but we're saying it's a type token object. And the syntax then, look, there's a java.util.array list of PlaceMark model, so we're specifying that's what we're actually reading into the mutable list with our kind of a close brackets there, and we're specifying a dot type. So that's a specific syntax that we need to use to be able to tell JSON what type of data that we want to spit out. So here we're specifying that we'll be working with an array list of PlaceMark model objects. If, for argument's sake, you were only working with one individual object, you say it was a RESTful API and it was one update that we were working with, we would simply just have PlaceMark model listed inside here. Okay, I have collapsed there our generate random ID. You can see how that works inside the during the lab itself, and you can look at all the code. And again, just to highlight, there are serialize and deserialize functions. Okay, that's how we convert that JSON string back into a list in the deserialize. So we have our from JSON, and then we have our to JSON, which will take that list of mutable list of PlaceMarks and convert it into a JSON string, which we then write out to a file. Okay, so that's how that works there, and that's the overall kind of mechanism. Okay, this is what it actually looks like. So you can see here, here's the square brackets there again, just to kind of recap on the whole JSON kind of syntax. So our square brackets identifies an array, whereas the curly brackets identifies a particular object. So if we see here, this is again when we set our pretty printing, here's one particular JSON object, So that would evaluate to one placemark model object that would have been inside our placemarks mutable list. And here we have 1, 2, 3, and 4, which is what we get over if we look at it here. So that's kind of what we get printed out there as well. So that's the equivalent. So if the user did a list or did to print it out, that's what we get. So that's our the actual physical file itself, placemarks.json, which you could view externally from the application if you needed to. Okay, and that, I think, yes, that wraps that up. Some of the same references as before, and that concludes the overall placemark console version. There is actually, what I think of it, a kind of a Tornado FX. I think I might have the lab at the end of it, just to show you that Kotlin isn't restricted just to Android. It can be used in a lot of other kind of environments, and that's running with similar to Java FX. Is that kind of nice Windows UI, but you could build a desktop application with it. But for the moment, as I say, that concludes the our console placemark implementation. So what we will look at over the next few weeks, we'll be bringing in Android applications, and then myself and Eamon will be working on 2 different case studies, but we'll talk about that then. Okay, so thanks for listening, and